Hey all, this is just me going through a few of the problems on the quiz review today. I'm sorry, on the quizzes today. Um, excuse me. The quiz is only on the nth roots and the rational exponents. Um, the first few things here are just, you'll probably see one or two from part one or two. From parts one and two, just going back and forth between exponential and radical form, just making sure you understand the basics of writing them in either form. For number one, this one would just simply be, if you're writing in an exponential form, x, remember that it's going to be x to the a over b, and b, or a is the power, and b is the root. Again, I think of it as division, so you think of it as like dividing by like b, so that thing goes on the outside. And so when you're going back and forth, this will be our b outside, and this will be x, and the power is underneath. So if I'm writing this in exponential form, the power goes on top, the root goes on the bottom. The default root, if there's nothing written, is the square root. So it will be 5 over 2. And this will be y to 7 over 2. This will be our answer in exponential form. For number 2, again, the power goes first, so it'll be x to the 8 over 12. One thing you will want to make sure that you do on the quiz is reduce any powers. If they're fractions, it should be reduced. So 8 over 12 can reduce to 2/3. So you'd want to make sure your final answer was x to the 2/3, not the 8 over 12. And then for the last one, this will be x, 5 over 5, y, 2 over 5, and z, 8 over 5. Now, it being improper is perfectly fine as far as the numerator being bigger than the denominator. You don't have to worry about doing anything with that. But if it does straight up divide, like you see here for the x, again, it should be simplified. So you should write that as x to the 1, which obviously you wouldn't need a power for. All right, so this will be our answers for the first 3 problems. Moving on for part 2. For part 2, I want you to write them in radical form. So it's just the reverse. Again, power is what's on top, so it stays with x, and then the root goes outside. So it's the cube root of x to the 7th. And you can, here it says make sure the radical is simplified. So that means we want to make sure it's like we're applying our nth root rules. That's what it means to simplify it. So even though this, might have been correct in the past, if I'm specifically asking for you to simplify that root, you want to simplify this, and this will be x squared, and then there's 1 left underneath there. So this would be the technical final answer since I asked you to simplify the radical. All right, for the next one, number 2, this is a 5th root for everything. So 5th root, this will be x, y squared, and then it's z to the 8th. Again, since it specifically asks you to simplify that radical, we want to make sure that we do all our nth roots and everything's done. Everything that can be simplified is simplified. This is the only one that can be. So we take out 1z, and then under the 5th root, we still have an x, we still have a y squared, and we have a z to the 3rd because there's 3 z's left over. That will be our final answer. And here for the last one. Before I even wrote these as radicals, I would take a minute to reduce these fractions. Again, any fraction that's not simplified wouldn't be correct. So let's make this 3/4. And let's make this 1/2. So now we can put everything into the radical form. So this will be the 4th root of x cubed, square root of y, and the cube root of z. So this will be my final answer. Since they all have different roots, they have to be under their own separate radicals. They can't be together. All right, so hopefully that was simple enough, just writing them in radical form. All right, so this next section is just going to be applying the rules that you need to apply for the different exponents, but now these are all going to be the rational exponents, so the fractional exponents. It says to leave the answers in exponential form, so we don't have to worry about converting it to radicals. We're going to leave it in exponential form. So this will be 1 over x to the 1/4. Remember, the main issue here is that it has a negative exponent. A negative exponent is not considered simplified. That would be my final answer. When you multiply, the rule is that you add the exponents. So we need to be doing 3/4 plus 2/3. Again, if you have a calculator, you can just key the fractions in. It'll automatically convert to common denominators. If you do not, make sure you do that. It'll be 3 over, or not 3. The common denominator will be 12. And our situation here, we're multiplying by 3. This will be 9/12. And here we're multiplying by 4. This will be 8/12. When we go ahead and add that, we'll end up with x to the 17/12. Again, it says to leave it in exponential form, so we're good. You do want to make sure you reduce any exponents, but you want to leave it as an exponent. You don't need to do anything else. For example, 3, when you are dividing, the rule is that you keep the base and you subtract the exponents. So we need to do 3/4 minus 1/5. 3/4 minus 1/5, common denominator is 20. This is 4/20ths and this is 15. Subtract, you get 11/20. Again, leave it in exponential form. When it is a power to a power, for this, our rule is going to be that we multiply the exponents. So this would become, keep the x, and we're doing 1/8 times 2/3. When you multiply the top, multiply the bottom. So our answer will be 2 over 24. Now that can be reduced to x to the 1/12. Again, make sure you reduce any rational exponent. For the next problem, number 5. For number 5, we have the x's that can be combined. So we'll have x and we have the 2 y's that can be combined. Now essentially we have to add those fractions because when you multiply, the rule is you add the exponents. So we have 3/5 plus 2/3, because those are the exponents for the x's. So we need a common denominator. This is 15. So this is going to be times 5, so that's 10/15. And this is times 3, so 9/15. So it's going to be x to the 19/15. And then for y, we're going to be adding, for that one, we're going to be adding a half and a 1/5. A 1/5, doesn't matter, but 1/5 plus 1/2. Common denominator is 10. This will be 5. This will be 2. Our answer is going to be 7 cents. So this is our answer. Number 6 is probably one of the trickier problems with these, and because there's 2 different operations in one. First thing you would do, we've done this same type a few times, is the bottom. When you do the bottom here, you should end up with x. Common denominator, this will be 3/6, and this will be 2/6. So it'll be x to the 5 over 6. So this is going to be x to the 2/5 divided by x to the 5 over 6. We still would need a common denominator because at this point we're dividing. When we divide again, we subtract. So now I need a common denominator for 2/5 and for 5/6. So the common denominator is 30. And up top, we're going to end up with 12/30ths. Because we're multiplying here by 6. This one we multiply by 5. So we get 25 over 30. So in the end here, we're going to end up with x equals, this is going to be negative 13 over 30. We can't have any negative exponents. So we're going to have to rewrite that. And our final answer here would be, sorry for space, it'll be 1 over x to the 13/30th. Pretty small. Let me try to make it a little bigger. All right, well, hopefully that's clear. But it's 1 over 13/30th. All right. For number 7, this is the last one I'll explain in detail. The next couple I'll just throw the answers up. For 7 here, or the last one in this section, this will be x. Right now, you can't do anything with these. The reason is because they have different roots here. This has a 5th, and this is a 3rd root. So we need to, excuse me, the best thing to do here is to convert it into exponential form and then work with it. So this will be x to the 2/3, and this will be x to the 4/5. And when we work on this, we add the exponents again. So we got 2/3 plus 4/5. Common denominator again for 3 and 5 is 15. This is 12, and this is 10. Our answer is going to be 22/15. And again, all answers can be left in exponential form. Okay, so here are the answers to numbers 8 and 9 from this section. Again, they were concepts that were previously reviewed here. Just wanted to make sure you guys saw the answers. Let's move on to the next section. Section 4. This is our final section dealing with the nth roots. So for our nth roots, it says here to leave your final answers in a radical form. And let's begin. So for number 1, our default root is square root. So we don't see anything there. We know it's a square root. So for this one, we're going to just start off with the square root of 64. The square root of 64 is 8. And then the square root of x to the 8th. Again, you divide, in case anyone's not sure. You're taking these exponents here and you're dividing it by the root. So we're essentially doing 8 divided by 2. We get 4. This is going to be x to the 4th power. And then we're doing 6 divided by 2, which is 3. So we get y to the 3rd power. Now, we do require absolute values whenever we have an even base here or even root and it comes out odd, because we want to ensure that our answers are always positive when it comes from an even base. So that would be our final answer with those absolute values. For number 2, again, we have a square root because it's nothing there. That's the default. And with this square root here, we need to make sure that we realize this is a negative. Whenever there's a negative number under an even root, it's going to be imaginary because it really wouldn't exist. This is going to be 9i. Then here we have some other issues because 3 is not evenly divided by 2. We have a remainder or some leftovers. So in this case, what you do with that remainder, this is basically 1 and 1/2. The whole number comes out, so this will be x that comes out of the absolute value, and the leftover x, because there's 1 left over, stays underneath the radical. For the y, we're doing 12 divided by 2, that's 6, so y to the 6. And then for the z, we're doing 5 divided by 2, which is 2 wholes, and then there's 1 left over. So for the z's, there's 2 wholes, so we put a 2 on the outside, and then there's 1 left over. That 1 left over stays under the radical. Oops, make it a little shorter. So this would be our answer. Now, we still have to worry about what I said for the first problem. This is an even root, and if we have any odd powers, we want to put absolute values here. So for this one, we do have 1 odd power outside of here. That's the x, so that would require absolute value. Okay, let's move on to number 3. For number 3, we have a negative number again, but this time it's an odd root. So if it's an odd root, it can be negative because negative 2 to the third power is negative 8. So we have no concerns involving i's or imaginary numbers when it's odd. Okay? And we're going to do the same thing. We take the roots and we divide them. But this time we're not dividing by 2 because it's 3 is the base or 3 is the root. We're dividing by 3. So this will be x to the third. 15 divided by 3 is going to give us 5. So it'll be y to the third. I'm sorry, y to the fifth. And then 17 divided by 3. Now that one again is not going to go in evenly. It'll be 5. But then there's 2 left over. So it'll be z to the fifth. Again, the whole number comes out. The remainder stays underneath the radical. So there was 2 left. So it's going to be z squared under that radical there. Now again, when it is an odd root, negatives are fine. So we don't have to worry about needing any absolute values or anything like that on the outside. For example, 4, we only have the one term. So we're just doing 24 divided by 8. That's 3. Our answer is going to be x cubed. It's an even root though, so we will need absolute values out here. So just going to throw those in and we're done. So that's pretty much our process, and we just continue through these last couple problems here. For number 5, we're doing the fourth root. Now this plus or minus is already on the outside, so we're just going to keep that. But if it's on the outside, we just keep it. And we're doing the fourth root of 16. The fourth root of 16 is 2. Be careful, this isn't square root, it's fourth root. So the fourth root of 16 is 2. And then again, this time we're dividing by the root. The exponents get divided by the root. Divided by 4 is 1. That's going to be x to the first. 12 divided by 4 is 3. So that's going to be y to the third. And 23 divided by 4. Again, this time it's not going to go in evenly. It'll go in 5 times. And there's 3 left over. So 5 3/4. So that'll be z to the fifth on the outside. And then underneath the radical, make sure you put the fourth root there. It'll be z to the third. Again, the remainder goes under the radical. Now for this one, we do have to be concerned about odds and absolute values because it's even. Again, any even root, that's a concern. And we have all of these that are odd, so we can put absolute values around the whole bank there. All right, I'll do number 6 with you guys, and I'll just post the last couple of answers. So here we go for 6. 60 divided by 6 is 10, so that'll be x to the 10. 24 divided by 6 is 4, so that'll be y to the 4. And 18 divided by 6 is 3. That'll be z to the third. This is an even root, so we do need to worry about absolute values around any odds, and we have 1. So that's our answer. All right, guys, so these are the last 2 answers for 7 and 8. Have a great day. Good luck on your quiz.